Hey everyone, it's Jim
And Charles.
from Valves and More, an online vintage tube store. And today in Tube Lab number 236, we're going to talk again about cleaning up noisy tubes.
Well, not just tubes.
Well, sockets, and you can actually apply what we show you to other pieces of gear like RCA patch cords, etc. And it is a revisit of a topic that we've gone over a number of times, and
We probably will again, but it's good to come back to it every now and then.
yeah. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Well, the number one problem with any tube gear is noise. Now, I'm not talking about scary noises that have you racing to push the off switch and immediately having visions of an expensive repair bill. No, what I'm talking about is wee bits of noise, sometimes scratchy, sometimes white noise. White noise is just a broad frequency band that sounds like shh, something like that. Anyways, I guess we could have made some for you, but we're lazy. Sometimes it can just be a tiny little click every once in a while. Almost all of these irritating noises can be traced to either the tube or electrical connections that aren't 100%. Now, some of them can be from electrical interference in adjacent pieces of equipment and from the air, and that's a totally different topic.
And it tends to sound quite a bit different too. It'll be more like a repeating pulse. You know, like in the old days when you'd have your cell phone near a speaker, that kind of noise.
Well, you're dating yourself, Charles.
Yep.
It can also be a high-frequency buzz, which is something that plagues one side of our system simply because we've got a lot of high-frequency electronics nearby that are all related to our TV and Wi-Fi. But anyways, well, let's just deal with one thing at a time. So before you condemn any tube, try cleaning up the contacts in your system and see if you can catch it. This happened recently on our GU50 kit monoblocks that have now been in service for years. And sure enough, after Charles thoroughly cleaned the pins and sockets, the noise was gone. Now, he only did one channel, and by rights, we really should have done both amps at the same time. But yeah, we're lazy.
And they're heavy.
Yeah. But it's not actually a big job. So
No, it only takes a few minutes, really.
yeah. Now, what is the cause of these poor connections with 3 question marks? Oxide buildup. Now, it can be other contaminants like grease off your fingers and contamination from the air, but oxide buildup is probably the majority of the problem. So as metals get exposed to oxygen in the air around us, they slowly form an oxide layer. Now, in some cases, this layer is beneficial in that it helps prevent corrosion. In our case, it's just the opposite, and we want that oxide layer removed and the underlying bare base metal nice and bright. Okay, so this is a practical show, so we're going to show you all sorts of methods that we use on a regular basis in our labs to clean up tubes. So, Charles, why don't you jump in and start with some of the tools and techniques.
Okay, well, let's start off by just looking at something like this guy right here and talking about how to straighten these pins, first of all. It's not quite in the same vein as cleaning, but these guys need a straightening and a cleanup as well. You can see we've got a lot of junk and oxide on here, and clearly this tube has been bouncing around.
Yeah, now all these tubes came out of our dead bin.
Yeah.
And when you see, this is obviously a pull, so it's a used tube from a piece of equipment. When you see bent pins like that, there's a very good chance that somebody got into the pins with a pair of pliers and started bending them, hoping to get a better connection.
Or the tube was sitting in a socket and got knocked, something like that. And that's why a lot of them can get bent over that way.
So bent pins don't condemn a tube, but it's often a very good indicator that the tube is done.
Yeah. Now, these guys are so badly bent that we can't actually hit it with the tube straightener or the pin straightener right away. What I would do first is come in with some smooth needle nose pliers, and just very carefully, you want to sort of grasp the entire pin body.
Now, don't go too close to the glass or you risk actually fracturing the joint where the pin goes through. So pull the pliers back. See how Charles is just a wee bit
just
off
a little
of the
bit
glass?
off. And I'm just going to gently squeeze the pliers, and that's going to help bring it back in fairly straight. Now I'm just going to work my way around here real quick. We're not going to spend all day on this tube because it's junk. And I'm just going to get them roughly where they should be. If this is all you have, if you don't have a pin straightener, you can use these and carefully straighten all of your pins back to where they should be.
Yeah, and you'll probably go around once, twice, even 3 times before you get them. They don't have to be perfect, but they have to be close, that they'll fit into the socket.
All right, so that's looking a lot better already. Let me get that in focus.
Look at how oxidized those pins are. And there's also probably some other contaminants on there. So there's lots of options. Now, the simplest way to do this, if you don't have the rest of the equipment we're going to show you, is to simply scrape the pins. And that means you need a mini box knife with the tight or low angle tip. You see how at the very end we've got a very shallow angle? Most box knives are at 45 degrees, but this is, I think, at 30 degrees. And that makes a big difference, allowing the knife to get in nice and close.
So what you want to do is, I like to start on one edge of the pin, and I'll work my way around and just gently scrape off that oxide layer.
Now, we're not going to do all the pins. We'll just show you one, or this episode's going to be an hour long.
So you can see there,
it's starting to come clean.
This can take a bit of time, but it does work.
Now, what about how we do it on our benches when we have hundreds of tubes to clean in a week?
We like to use these flapper wheels, and this is sort of like a replacement for a brass wire wheel. It's a lot safer. You don't get little tiny brass wires all over your floor sticking into your socks and all that sort of stuff.
Caution, if you do use a wire wheel on a Dremel, make sure that you wear eye protection.
Oh yeah.
And whatever you do, don't do it in a space that you walk around in socks.
And good idea to wear eye protection with these too. They are a lot safer, but these little tines can come off if they hit something that's a little too rough.
Now, normally they're loaded onto the Dremel spindle as singles, but if Charles will show you what we do, and that we actually stack a pair of them.
Yeah, so we'll take 2 of these discs, and you can buy these actually in kits, and they'll come with a wide variety of abrasiveness, and I think they start at 80 grit and go up to maybe 300 or 600 or something like that.
I think we're typically using 120.
Yeah, these are 120s right here, and I find that they're the best balance. If you go too light on the grit, then it just takes forever to clean a pin. If you go too heavy, the wheels wear down very quickly, and you take off a lot of material.
Yeah, and of course the grits are color coded.
So here's one that Dad likes to use. He used it for a bigger job recently, and this one's dark green, so that's an 80 grit. And just real quick, I'm going to turn down the volume whenever I do this on the video, so it's not going to blow out your eardrums here, but I'm going to quickly show you how this does on the pins here. Let me get that back in focus. Take a look at that. What a difference from that to that.
Yeah. Now you can't, with the wheel, you can't get into every nook and cranny. And that's where scraping can help. So on a really badly oxidized set of pins like this, if it was a high value tube, and we were hoping it's going to still test at least good used, then we would clean it up even further. And grab the pin straightener. Have you used it yet on camera?
Not yet, so let's bring that in.
Pin straighteners are amazing.
Unfortunately, hard to find good ones.
Yeah. In fact, this is the only one I've ever found of this type. What's the brand name on it? I think it's CBS.
This is a CBS, yeah.
Yeah, it's a CBS. That's a Hytron. No wonder it's good.
And so I'm going to push it in again, and there we go.
Yeah.
So that's good enough to use in a socket if we cleaned up the other pins on it, of course.
Yeah. So after cleaning, of course, it goes into the tester. Most likely that tube wouldn't have passed, and we would be chucking it back into the junk drawer, which is where it was.
Now, there is another way that we've heard about recently that some people are using, and that's to use these magic erasers. It's just sort of like an abrasive sponge, a very mild abrasive.
And for bigger pins, like
I wouldn't use it on something like this. Although you probably could if you're careful. But for maybe an octal, it might just work. So
now this is a good example of a pin that actually doesn't look too bad, does it? And in fact, it looks like there's no problem at all. So the question is there an oxide layer or isn't there? So
let's bring this in, and I'm just going to very carefully attack that pin, and let's take a look at that.
Okay, so you can see a difference.
There's before, there's after.
So why don't we hit
look at what came off on the abrasive here.
Yeah. So why don't we hit it with the wheel and see what happens? And again, you can see right away pins that looked like they were clean, in fact, were oxide. Because if Charles goes back the other way a little bit,
well, these are the oxidized ones
and then
here.
go back, and there's the cleaned up pins.
Yeah.
Yeah.
So it just makes a big difference.
Yeah, and of course that oxide layer is going to definitely interfere with the electrical connection. Will it turn off the electrical connection? No, most likely you're going to have a decent electrical connection because sockets are designed to try and lightly scratch and grab the contacts.
Mm-hmm. So if you take a look at this guy right here, this is one of our standard PCB mounted octal sockets, and you can see it has sort of a blade on each side of the pin. And so as you mount the tube in there, these are actually going to grab it and slightly cut into the pin. And that's actually a good way to tell if a tube has been heavily used and put in and out of sockets as well, is because you'll see those gouges along the length of it. This one actually really isn't that bad, but if this had been inserted and removed a whole bunch of times, you would see lines up and down it.
Okay, now what about those sockets? Is there a way of cleaning those things up? Well, if it's a really big socket, you can take some fine black paper, 400 to 600 grit, let's say, cut a little piece off and make a very, very, very tight roll with it until you can get it in. Now, that's going to be more applicable to something like an RCA jack. In fact, let's just clear the decks of some of these tubes and we'll be right back. Okay, so this is actually the PCB for the modern line rocket preamp, and we actually build finished kits for some customers, though the majority of customers buy them as kits. And when you're done soldering an RCA jack, let me just show you if I can. Can you see here? Maybe Charles can get a pointer going. Right where we solder the center contact
here
to the PCB, we have to put a little bit of flux to make good contact. Mm-hmm. And some of that flux and sometimes a little bit of junk from heating up the contact point will actually flow into the area where the RCA jack contacts. And this is going to apply to any build. There's no way to get those sockets on mechanically, so they're always soldered in place. So there's a very good chance that even if you have a relatively new amp, if the socket wasn't cleaned up originally at the factory, and they probably aren't, then there's a very good chance that the contact has a little bit of gunk on it.
And if it's an old amp that you're refurbishing or you just got secondhand or something like that, then it could also have an oxide layer built up right on the inside.
Okay, so how do we clean up these tight little spaces? Well, you could roll up your little bit of black paper and in it goes, and you could just do a very gentle little turn in there, and you will basically abrade the contact. It's not my favorite method because you're going to actually be taking a little bit of material off the area that actually pushes the pin over up against the contact. But if you're using 600 grit paper, it's probably just fine. And for really problematic sockets, from vintage equipment that are now 50, 60, 70 years old, this might be the only way to really get them clean. But for any kind of receiver that is in relatively good shape, deoxit is your friend. Deoxit is just a chemical cleaner. It also leaves behind a component that will help improve the contact in the future. This is the high strength stuff, so that's 100%. So that's the powerful stuff. It does come in a can like this. This is D5, and this is, I think, 10% deoxit, and the rest is just a solvent that is in the carrier. I'm not a big fan of spraying this all over the place, but you could use this in a pinch. What you could do, though, is buy a sample pack of deoxit, which comes with all different sorts of the cleaning solutions that they sell. This is the red version. This is equivalent to the D100. In fact, I refill this from here, and it's got a neat little brush in it.
And that might not look like a whole lot of deoxit in there, but it goes a very long way. You could do a lot of work with that little bottle.
Yeah, so you actually want to be very careful not to slop this stuff all around. A little bit does it, and I'll get that a little bit. So you can just put a little bit in here, and you basically just let it sit. And if you've got a really big corrosion problem, you can come in with a cleaning tip like this. These are amazing. And to use this, you would do something like this. So you just load that up, and I actually put a little bit too much on there, but anyways. And then you just come in and you clean it, and you could come back with, if I can find it, I have another swab here somewhere.
There it is.
And you could come back, let it sit for 10 or 15 minutes, and come back and then just clean it off again. And when I'm restoring vintage equipment, mostly reel-to-reel tape machines, I'll come back on a socket that's 50 years old, and this will be almost black with oxide. So I'll come back and give it a fresh treatment and come back again. And the last time I clean it, I'll leave a little tiny bit of residue. I'll just leave it here in the socket, just like that. And that's it. It'll be fine. It'll actually help keep the contact maintained. Okay, now what about tube sockets? They can be really problematic. So Charles is just going to clear that off the decks. So here are two very common sizes and one that's not so common. So this is a miniature 9-pin, and these are a pain in the you-know-what.
But at least these ones are open. There are a lot of miniature 9-pin sockets that actually have just a tiny pinhole here.
So the same thing. You could use a little brush with the deoxit, or you could take your bottle of D5 and just apply it to the tip here, just a wee little bit, and just come along and just basically work it in there. You can see how I'm spinning my tip a little bit.
You don't want to put too much pressure because it will just shred that, that cleaning tip.
Now, if that comes out clean like this, you're done. Just leave that little bit of D5, or D100 in this case, in there. And Bob's your uncle, you're good. If you've cleaned the pins on the tubes, you're good. Bigger sockets like the GU50 socket, this is a used one, are a lot easier because you can get the whole thing right in there. And maybe not so much in there. These are
they're still fairly tight on this one.
They're
If it was a
fairly
used
tight.
socket, it would be pushed apart a little more.
These here, we can get in a little bit. So that's probably enough to clean them. Each and every type of socket, though, is going to require a little bit of thought. What's the best way to do it? Do I just come in there and brush a little bit on and walk away? It's always preferable, though, if you can come in with some sort of a cleaning tip and not a Q-tip. Q-tips are going to leave shreds of cotton fiber and fluff all over the place, and they're probably going to cause more connectivity issues than they solve. They might have some applications somewhere in cleaning up equipment, but these fabric-coated types of cleaners, they are just the best thing that I've ever found.
Yeah, they're perfect for the job.
And if you can't find them and you could use a few on your bench and you've got an order coming in, just drop me a note on the order and say, Jim, could you include some of those really nice looking tips? I wish I could send everybody sample packs of deoxit, but this stuff is actually not cheap. So you're going to have to source your own. And it does go an incredible long way. For years, I just had a couple of sample packs that a gentleman actually that I bought a piece of equipment from gave me the first sample pack years ago. And it took me a number of years to use it all up, or most of it up. And I just ended up buying another sample pack. But, as I got into restoring more and more equipment, I ended up just buying the concentrate in bulk and just reloading from there. As I mentioned before, this has a real heavy solvent content. So when you use this, it's not nearly as powerful as when you use the concentrate. So if you do use something like the spray can and you don't want to make a complete mess, just set up a little plastic cup. I think we've got one on the bench over here. So what I've done in the past is I've taken the spray can and I've just clean out your cup. I just shot a little bit of the spray into the cup, and now I can just come in like this and I can just pick up a little bit on my cleaning tip, and Bob's your uncle. Anyways, there are probably more ways to clean contact surfaces than we have time.
But this is what works for us, and it's fairly easy, and it should cover you guys too.
Yeah, so never throw out a tube or give up on a tube until you're absolutely certain that it is in fact the tube that's causing the noise and not some contact in your system. RCA cables are notorious for this problem, and you can use the same kind of techniques that we've shown. Be more gentle with things like the platings that you will find on a typical RCA connector. So I wouldn't do mechanical cleanups in most cases. I would use mostly solvents like deoxit to do the cleaning. And you might wonder, do certain tubes have more problems with connectivity? Yes. Metallurgy changed from the 1920s to the 30s to the 40s to the 50s, and some tubes are more problematic than other tubes. Some tube pin diameters are bigger and smaller than others. So it's possible that if you've changed into a set of tubes, that the tube you took out had a larger diameter pin, and as a result, the contact's not nearly as good in the socket. And so cleaning up the contact area in the socket might actually help with that, but resetting the socket might be a better way of doing that. Caution, there's high voltage present at the pins of these sockets. So this is a whole topic for another episode, but hopefully that gets you going as far as cleaning tube pins and sockets. Now, Charles, do we have some tubes to show off today?
I think we do, including one really, really weird one that I thought was fun to show off.
Okay, well, let's clear the decks and we'll be right back. Okay, Charles, what have you found for us?
Okay, we'll get to these guys in a minute here, but let's take a look at this really neat old RCA box. And this is a good lesson for people to never take at face value what it says on the box. Now, this doesn't have its original label on it, but it does say that we should expect a VR150 inside here. The VR150 is just a voltage regulation diode. And I was actually looking for some earlier today for a customer, and I pulled this thinking, oh, this looks like a really nice vintage one.
Oh my God, what is that?
And that's not a VR150. That is an 8025, and isn't that a really cool looking tube? So this is actually a UHF transmitting triode that can output 40 watts if it is forced air cooled, but 30 watts if it isn't.
And how many volts can it take on the plate?
1,000. You can see why it has these really big caps on there and this interesting glass bottle. I bet that's meant to go into a socket receiver or something.
Caution everyone, high voltage is present.
Yeah. Isn't that neat though? Okay, enough of the weird stuff. Let's get to the stuff that you can actually use inside of an amplifier. And here we have these beautiful Rogers GTAs that we showed off last week, and they have been selling. People love these tubes. We still have some left. I think we were hoping they were going to last a little bit longer than they have.
Yeah, and the reason we're showing them is to let you know that they will be sold out shortly.
Yeah, and we have no way of getting more of these. I mean, they may trickle in one tube at a time over the year or something like that, but
well, why don't you back up a little bit and just rotate it around. There's actually a little split in the mica, which is worth showing. Keep going.
Let's
Keep
see
going.
if we can get that.
There it is. It's on the top mica.
And on the bottom.
Is there a split on the bottom? No.
Oh, do you mean this right here?
Yeah. So what happens with micas is it's actually a natural material, and it's a very good insulator, and it's lightweight, it's strong, and it comes in very, very thin layers. That's how it's actually formed. And occasionally it'll just simply develop a little split. And it's not going to affect the tube's performance in any ways. It's just a small aesthetic issue. And we wouldn't condemn a tube for something like that. Simply because quality vintage tubes are just so rare that...
And it doesn't affect the sound.
Yeah, it doesn't affect the sound.
Occasionally you'll also see a sort of little flake coming up as well instead of a split. And as long as it's not bouncing around inside of there, that should be okay too.
Yeah.
Yeah, so we still have some pairs of these left in the store. They're excellent tubes. They sound exactly like the Sylvania GTA angle plates. And
which is one of our favorite 6SN7s. Yep. Somebody actually dropped me a note, I think this morning or overnight, asking if the GTBs weren't the better sounding tube, which I thought was interesting. I don't know who in the world would be talking about the GTB being superior. The sequence of manufacturing for all 6SN7s starts with the GT. GT stands for glass tube. That was the first generation, and they were first issued, I think, in 1937. And along came the GTA for the Second World War, so the 1940s. And by about 1960, maybe the very last years of the 50s, the GTB came along. And in the case of Sylvania, or the Rogers Sylvania tubes, in which Rogers is building with Sylvania parts or assembling with Sylvania parts, the earlier Sylvania tubes tend to sound better than the later ones. So the GTA sounds better than the GTB, and the GT actually sounds better than the GTA, but is a different sound. And it's a very different tube. The specifications of the first generation mean that it can't be played safely on modern equipment. The exception are amps like our Universal 6 or 12 SN7, which can play any 6SN7 ever made because it's actually biased. So the power of the tube output is set up in a circuit that uses the original datasheet of the GT, which is almost a full third lower than the later
it's considerably
GTA.
lower voltage and wattage ratings on it.
Now,
But that's not to say the GTBs sound bad.
no, the differences are not huge, but for an audiophile, you would hear them instantly. So the GTA is a great compromise because the GTA was the first of the modern 6SN7s and essentially has the same specs as the later GTB. The difference was in the filament specification, not in how the electrical parameters operate.
So they can run in any modern circuit.
Yeah.
And they're one of the earliest tubes that can run in any modern circuit, which makes them really, really nice.
Yeah. Okay, what else have we got, Charles?
Okay, well, we've actually been noticing a huge uptick in interest in these tubes recently. I guess somebody out there must be talking about them. And these are the Photon 6N6Ps, and this is actually the earlier version of them that have that square getter on the top.
Now, we use them as followers, cathode followers, in both the kit rocket preamp and the kit
Phono
preamp, and they are just amazing tubes. And if there's demand for the 6N6Ps, it's because we've talked about these on our other channel and how we really like the quality of the sound with them in the follower position. They can push current, and they're a little fussy to get operating cleanly in a circuit, but not impossible.
Well, they have a mixture of a high amplification factor, well, medium high amplification factor and a lot of current. So that means if you get the settings wrong, essentially, they can really push a lot of current very quickly.
And they can essentially run away. They can start to oscillate. So you have to, as a designer, we have to be really careful with that. But we have some tricks to get them stable in circuit. But sonically, they're just amazing sounding tubes. But this is the rare version, isn't it?
Yep, it's one of the more rare versions. There's a few different Photons. There's one that actually has a round getter on there, just like the much more common NEVZ tubes, which are also fantastic sounding. But these Photons are just so much more rare. People seem more interested in them. The big tell if it's a Photon or not is if it has these little folds. I don't know if I can get that on camera. You see that little fold over from the top of the plate?
And of course, they're the only type of 6N6P that I'm aware of that had the square getter.
Yeah, I think so. There was an earlier version of the Photon that had these sort of spot welded plates that look quite a bit different. I think we've only ever seen maybe 2 or 3 of those. They must be incredibly rare. But the reason we're bringing them up here now too is to let people know that we test them 2 different ways. We actually test them for GM, which is the top set of numbers here. So this is its voltage amplification.
And that's over 100, right? So a typical new old stock number on our tester, not all tube types, but most tube types would be centered. The new old stock number would center at 100. So 106 over 100 means that we are 6% over new old stock.
Yep. And the bottom number is our milliamps. So this is the amount of current that it's pushing per plate at that same operating point. And we match them this way so we can make sure they are set up for voltage gain circuits and for cathode follower or current pushing circuits.
Right. I think there's actually a shed amp that uses the 6N6P, isn't there?
There's a few different ones actually. And so making sure that they're both voltage and current matched will really make sure you get the most out of your tubes.
Okay, well, thanks for showing those off, Charles. And actually, we were trying to think about where we found all these rare tubes because we actually have quite a few of them in inventory. And you know, we buy so many tubes so often. I honestly can't remember. I had a question this morning from a gentleman. What is the source of the tubes that I just purchased? And I'm like,
It could be anywhere.
There's not a hope. We buy tubes all around the world. A lot of them come in from dedicated wholesalers and contacts, and we've got tubes that go back years and years in our inventory. Sometimes we actually lose them, and then Charles will find them one day and say, "Look what I found, Dad." And talking about finding things, here's some discount codes that will help you find some cash for your next purchase. There's a secret code that's really easy to figure out. And we can reach almost everybody around the world with $20 flat rate shipping. And if your order is $150 or more after discount, the shipping's on us, folks. Stay safe, everyone. This is Jim.
And Charles.
Signing off. Cheers, everyone.